Hi, this is Phil Goff at Flex Power Modules, and welcome to this new product introduction video for one of our latest releases, the BMR313 series of intermediate bus converters targeting datacom, AI, and hyperscale computing applications. The BMR313 is our latest generation of intermediate bus converter, or IBC, developed in collaboration with onsemi. Designed for applications that have large power demands and limited board space availability, the tiny 23.4 by 17.8 by 7.6 mm device packs in a huge 1 kilowatt of continuous power and delivers a peak power capability of 3 kilowatts, which equates to a power density of a massive 15 kilowatts per cubic inch. Targeting applications such as AI, machine learning, and high-performance computing, the device accepts an input voltage of 38 to 60 volts, and the non-isolated, unregulated 4:1 input-to-output ratio delivers an output voltage between 9.5 and 15 volts at efficiency levels of up to 97.3%. With an MTBF figure of 8 million hours and an industry-standard LGA footprint and pinout, the BMR313 offers the highest performance in the industry in an extremely reliable design. As well as the BMR313, which is being released first, there will also be a sister product available in the form of the BMR314, which offers a lower power level rating of 900 watts continuous and 1500 watts peak in a slightly taller package that still measures just 9.65 millimeters in height. Both devices switch at a frequency of 1.25 MHz, enabling the use of smaller magnetics, and they're thermally optimized to provide the best conduction path to both the host PCB and the cold wall, which could range from a simple heatsink to more elaborate cooling solutions such as heat pipes and liquid cooled systems commonly found in these applications that use extreme processors. As mentioned, the BMR313 targets those applications that use ASICs, FPGAs, or processors such as CPUs and GPUs within AI accelerators, machine learning applications, and high-performance computing, for example. These applications demand an ever-growing level of power in the smallest solutions and have high dynamic load requirements, forcing the need for any power solution to be able to provide bursts of higher power levels for short periods of time. These IBCs complement downstream point-of-load converters and increasingly voltage regulators such as the BMR510 and forthcoming BMR515, which perform the secondary conversion down to the high current, low voltage core voltages. Here you can see the efficiency curves of the BMR313 over the entire load and at different input voltages. Looking at the 54 volt line, which is a very common supply voltage in the data center environment, you can see that the efficiency peaks at 97.3% at 50% load and still operates up to 96.4% efficiency at the full output rating of 80 amps. Power dissipation at the same conditions range from 15 watts to 40 watts. This high efficiency and optimized thermal design of the converter leads to excellent derating characteristics. As mentioned, these devices are designed for conduction-cooled environments, and as you can see from the graph on the left-hand side here, with a host board temperature of 60 degrees C, the device can deliver its full power rating even with a cold plate temperature of more than 75 degrees C, and derates to just 71 amps at a cold plate temperature of 90 degrees C. The graph on the right-hand side shows the capability of the device to deliver peak output currents of up to 220 amps depending on the pulse duration and actual temperature of the module at the start of the pulse. The package, as mentioned, is extremely small for the 1 to 3 kilowatt power rating, measuring just 23.4 by 17.8 by 7.65 millimeters. Connections are via an LGA LAN pattern, and the footprint is now considered an industry standard. The pinout is detailed here, and as you can see, pins 7 to 10 are used for the digital PM bus functionality. This includes an alert pin, which can be used for reporting of fault warnings such as overcurrent or overtemperature. We also intend to use this pin in the future to enable smarter power protection capabilities when the device is used for peak power demands. More details of this can be requested via our field application engineers. Samples of the BMR313 are available now, and evaluation boards can also be requested to enable easy verification of the performance of the device in your particular application. Please reach out to your local FAE or RSM, or you can email us at pm.info@flex.com. Thank you.